Hello, everyone. Today we have joined for the webinar series. We've prepared this first webinar inside a BUILDCHAIN project. And the topic of our today's webinar is OriginTrail, DKG, and the Decentralized Building Logbook for Sustainable Built European Built Environment. So we are really happy to have really interesting speakers today with us who will present and explain the underlying technology that is to power BUILDCHAIN in simple terms to our wider audience. So this idea came about with the us having the very interdisciplinary team, and we wanted each other to maybe get to know better what are the specific domain and the specific fields we are working in, but also then we've decided to open this webinar to wider public. So we are happy that you are interested in these topics and you have joined us today. We hope to kind of educate you or to prepare with this prepared explanation about the technological capabilities and also the impact that we aim to create in the construction industry that is changing and developing really fast now. So the BUILDCHAIN project will also hopefully raise awareness and the interest in these new technologies. And yeah, by that, I believe we can move on. I will shortly present the first two presenters. So first, short lecture, let's say, will be performed by Noemi Friedman and Filippo Landi. So a short introduction for Filippo. He's a junior researcher in the Department of Civil and Industrial Engineering in University of Pisa. He earned his PhD in Civil and Environmental Engineering 4 years ago. His research activities mainly regard the evaluation of climate change implications of structures and also infrastructure, and the assessment of reliability and seismic performance of existing structures. He's participating in the BUILDCHAIN project together with Professor Croce, and they are the coordinators of the project. Noemi Friedman, she's a senior scientist from the Institute for Computer Science and Control, STACI, from Hungary. Noemi earned her PhD in civil engineering, but since then she has shifted her skills to stochastic computations, data science, and machine learning. Her main research focus is to improve engineering simulations and decision-making processes by using measured data. She has demonstrated history of working in the cross-disciplinary fields of computational science, artificial intelligence, and civil engineering. So she's the main initiator of the BUILDCHAIN project, and proudly let's hear them both.
Thank you, Katja, for the introduction. And I wanted to ask Filippo to share the presentation that we will present together. And directly starting, so this is an introduction to the whole BUILDCHAIN project for the big audience and also for the consortium members. So let's kickstart right away. First, let me motivate the whole BUILDCHAIN project. So now that we are in the middle of the energy crisis, probably I don't have to explain to everyone why is it so important to make Europe in the energy independent and to reduce energy consumption in general. So for that, what is important to state is that it's estimated that over 40% of the overall energy consumption of the European Union is due to the building stock. So this already motivates our project quite well. Not to mention that besides the direct consumption of buildings, there are so many processes related to buildings, like surveying, testing material properties, or trying to find out about the exact geometry. So these processes are often done, but not used, but rather replicated again and again, because people don't share this information. The different stakeholders rather do these processes again and again on their own, and this also is a huge energy waste related to the construction sector. Another important issue in Europe is that our buildings are relatively old. And it's estimated that 80% of today's building will be still in use by 2050, which means that we have to preserve and keep safe these buildings, keeping in mind that many of those buildings represent a huge historical and cultural value, and we want to preserve this value. But at the same time, we would also like to hit the decarbonization goals by 2050. So this is an important factor. In general, what we would wish to achieve is to have a building stock which is producing less energy, which is more resilient, more sustainable, and in general, healthier. So we came up with the hypothesis that a key factor in this whole process is to first achieve a transparent, efficient, trusted data exchange. That's the key in achieving all these goals. And this is not new. This has been motivated already in the last decades. And it emerged in the direction of initiating the so-called digital building logbooks, to digitalize all this information about a building, to store different records, events, certificates like health, LEED, BREEAM, and so on, certificates, performance metrics, life cycle emissions in the form of a so-called digital building logbook. But the obstacles and the challenges about having this digital building logbook, that there's no interaction in between the different systems. We are lacking standardization. People store different data types. There's no motivation that this data storage, which is actually kept in an isolated manner, are shared in between the stakeholders. There's also this issue of security, because often such information can be very sensitive information. So these are these obstacles that we are fighting in general. So when we initiated and planned this BUILDCHAIN project, we laid down the following objectives. These first two objectives I mentioned already: to have linkages in between existing databases, tools, and sources, and to achieve enhanced energy efficiency, cost effectiveness, circularity, climate resilience, to have improved safety and health properties of the buildings. Then a key issue is how to handle a population of buildings, to be able to design renovation processes to achieve different goals. So an improved management and the renovation system. We want to have a trustworthy, transparent, and traceable logbook data. And tools which can help us with verification, certification, and use of application level proofs. And last but not least, we would wish to enhance collaboration in between the different domains and throughout the whole life cycle of the building, to increase the quality of the services by a so-called new economy built around this digital building logbook data. So we came up with an idea not to have an improved version of a digital building logbook, but still exploiting the use of a logbook. So our idea was to build a so-called knowledge base, a decentralized knowledge graph. You will see more about what this is exactly in the next talk of Branimir. But the idea is that we have all these users and actors like investors, public administrators, designers, engineers, building owners, and so on. And there's all this data available for the different actors for different scale of the buildings. Also, there's an environment where the building lives, and it's also important to keep in mind these environmental effects, to know in advance if a big flow is coming, for example, coming to the point of the climate change, which hit us really suddenly in Europe. We really see its effects, so we should keep this environmental data also in mind. And we have to look through the whole building life cycle of the building. And our idea that with the help of this decentralized knowledge graph, we can all integrate these different aspects. The different actors can be interconnected in some way with the help of the platform, by also creating a marketplace where the actors can share their data or offers. They can include their quality certificates, credentials. They can log in new data. They can tokenize this data and maybe even trade this data. So that's the whole idea, that with such a system, including some proofing and certificating system, we can generate a trusted data ecosystem economy, which is the first step to improve sustainability of the buildings, and throughout this we can do throughout its whole building life cycle. So I would like to give the word to Filippo, who will show how we will demonstrate these capabilities of the platform.
Okay, thank you, Noemi. It's a pleasure to share this presentation with you. Okay, so to achieve the objective that we plan and were presented previously by Noemi, we will start from an existing digital building logbook that is currently used by the municipality of Florence for the management and administration of a really huge set of buildings. We are speaking about more than 2,500 buildings. So we will start from this existing logbook, and we will extend it integrating several new data tools and functionalities. And to do this, we will make use of the decentralized knowledge graph, a blockchain-based solution that will be presented later in the webinar by Branimir. And the idea is that we will include in this new platform, specific building-related ontology. In this way, we think that the whole knowledge around the building life cycle can be logged, and by that continuously updated. We will provide the mechanism and interface for the relevant stakeholders to publish, trace, share, tokenize, and even trade data and model that we will have in a market economy. So we plan to integrate in the platform several use cases, functionalities, and application. As you can see in this slide, there is a summary of the expected use cases that are 12, and application. We have planned 6 new applications. So we cover many different fields in the project, as you can see from the use cases. We have use cases related to the life cycle assessment, the energy efficiency of buildings, but then we have use cases focusing on the structural behavior of the building, the reliability assessment of existing structure against, for example, natural hazard. Then we have use cases related to the management of large building stock, management of a renovation process, design process, and also construction economics. We plan to deploy and demonstrate the use of the digital building logbook in 5 pilots. So we have first pilot related to the proactive maintenance of a cultural heritage building in Spain, in Granada. Then we have a second pilot that is focusing on a completely different building, that is a new hospital in Slovenia. And in this case, we would like to demonstrate the use of digital building logbook also to improve the design of a new building in a BIM environment. Then we have other two use cases that are located in the municipality of Florence. The first one will show how to use and take advantage of digital building logbook for the management of an heritage and strategic building. That is the headquarters of the local police of the municipality of Florence, that is hosted by a monumental building, the Palazzo Poniatowski Guadagni. Then we have a use cases related to the management of a population of building. We are speaking about the school building in the municipality of Florence. And we would like to show how these tools can be used also to improve the earthquake resilience of building and the carbon footprint. Then finally, we'll focus the attention on taller timber structure, and we will demonstrate the use of digital building logbook to improve structural design concept. Overall, it's important to underline that one of the main aspects of the proposed platform will be the scalability of the platform. So we will follow in the design a multi-scale approach with the idea to integrate the platform with multi-level and multi-resolution BIM models, where the level of detail of the digital twin models will depend on the characteristic of the building and the investigated fields. So, for example, we can have a very rough model, mainly reproducing the geometry of the building that can be used at the urban scale for city model purposes, for example, for monitoring environmental climate data, environmental impact, distribution networks, and also to plan renovation intervention. Then we will have a more refined model that can be used at the local scale of the single building, for example, to monitor the preservation of architectural feature, the structural behavior of the building physical properties, and so on. As was already mentioned in the introduction by Katia, BUILDCHAIN is a highly multidisciplinary project which cover many different research fields. As you can see here in this slide, we have 12 partners. The University of Pisa is coordinating the project. Then we have a good balance of academic research organization and industrial partners that are coming from different countries in Europe, Italy, Spain, Slovenia, Greece, Hungary, and Serbia. And as you can see more in detail in the following slide, we cover many different expertise, and we hope to achieve the objective of the project with a highly collaborative work between our partners. So we have expertise in civil engineering, structural engineering, climate change related impact, preservation of cultural heritage, AI techniques, big data analysis, building health management, structural health monitoring, energy efficiency. Also, we have a very important IT expert that will provide the ontology of the logbook. Also expert in blockchain solution, as we will see later on. Then we have the economy and business model that will be very important for the marketplace that we plan to build around the knowledge and the building that we will investigate. And then we have construction companies, construction management companies, and also we have Open BIM developer and expert in the Open BIM standards. So I leave the floor again to Noemi for the project structure and the conclusion of the presentation.
Thank you, Filippo. As we are a bit late, I think, with the schedule, so I will wrap it up fast. In total, we have 6 work packages. The first and the last one is for project management and coordination, the last for dissemination and exploitation. By the way, we have a brand new website. You can see it on the bottom of the slide, www.buildchain-project.eu. Please, if you are not in the consortium, visit our website, follow our social media platforms. We will put always new information there. We are very happy to get feedbacks about our platform and system. That would be the ideal case, that we have as much interaction in between the industry and the construction sector as much possible. So we have 4 technical work packages. The first is about designing the whole platform and setting up these use cases, from which a few of them are already settled, as you have seen it presented by Filippo. The second one is to develop this decentralized knowledge graph. Again, you will hear about that part more on the second part of this webinar. And the third part is to develop the tools so that those use cases that we have set up, what we would like to do with this whole platform, is actually feasible. And the heart of the project is the 5th work package, where we have the pilots. So these tools, the use cases, and the whole knowledge graph platform will be tested on this pilot project. And to conclude, we wish to address different impacts. So as you saw, we hope that with the help of this platform, we can really make a step towards making our building stock more transparent, and by that more sustainable, resilient, energy efficient. And we have societal impacts. So because of the sustainability, we hope to accelerate this process to this twin, green, and digital transition of the construction sector. We also expect to have some scientific impacts in the long term due to these follow-up procedures that is hidden inside this platform. So, for example, the engineers can follow their design, whether it's really, for example, a building or a building shell is really behaving as it was designed, or a service is really bringing those qualities that was promised. So this can lead toward improvement and innovation capacity. We hope to link the project with these bigger European Union initiatives that you see on the right-hand side of the slide. And this is, in a nutshell, the idea of the project. And I think only we have a short time for questions, but this will be up to Katja. Katja, give you back the floor.
Thank you for the really, really great presentation. Thank you very much. Yes, the questions are welcome after each session. You can also post them in the chat box, and then also later on after the speaks, we will have a chance to have a discussion. For the moment, I believe there are no questions, so I will pose a really short one. Do you know why the construction worker quit his job after the company went digital? No? Because
no, Katja, I don't.
Because he couldn't hammer out the bugs, you know, in the new software. So with that one, let's head to the second presentation. This one will be specifically more about the OriginTrail decentralized knowledge graph. We call that DKG. This will be presented by Branimir Rakic. Welcome, Branimir. He's a founder and the CTO of Trace Labs, and also the architect of the OriginTrail decentralized knowledge graph, an open source technology stack employing some of the most advanced Web3 technology to help organize our most important assets, including construction and building data, creating artificial intelligence ready knowledge assets that are discoverable, verifiable, and valuable. Branimir, the floor is yours.
Thank you very much, Katya. That was a really beautiful introduction. And thanks for the previous presentation, Noemi and Filippo. I think it gave a really good context of the project. So I don't have to speak too much about the project. I'll try to spend my time explaining what the technology is about, what OriginTrail builds. And I'll try to squeeze in a demo in the end, very quick one, so you can get a feel of just the minimal Hello World-like features you can use. So having that said, I'm going to share my screen. Just 1 second. And you guys, please tell me when you can see it. I'm going to run the slideshow.
We see it.
So thank you very much. All right. So like we already said, today we will present the OriginTrail Decentralized Knowledge Graph. This is an introductory presentation. However, that doesn't mean there's not a lot of topics to cover. So I might be going a little faster for somebody. Therefore, it's designed that way so you can ask questions on more specific things later. Therefore, in order to cover all of the ground, let's start from the beginning. Why are we doing this, and what is the entire mission behind OriginTrail? OriginTrail is here to organize humanity's knowledge assets and make them discoverable, verifiable, and valuable. And what this means is a lot of things. We'll go into many of the details on the specifics in terms of technology today. But I'll actually start on going from more human level applications where OriginTrail is being used today and where knowledge assets are helping people as we speak. And here's a couple of examples that we'll quickly list on this slide. Currently, there's many global companies using OriginTrail already. They're sharing information through it. The first upper left corner application is called Trusted Factory, actually used to share security audits for over 40% of US imports by major US retailers such as Walmart, Target, Home Depot, companies who are generally competitors, yet they still share their knowledge in between each other. And one of them from Home Depot, actually, Ken McElroy, has a quote. You can see it online. He says that something like this was unimaginable to him if you asked him that a few years ago, and then yet today they do share very important information in a privacy-preserving, trusted manner through this Trusted Factory project built together with the British Standards Institution. Another application is a rail travel safety set of applications actually built for on top of the OriginTrail DKG, or short for Decentralized Knowledge Graph, for the Swiss railway companies. So they basically track rail parts all across Europe to ensure the safety of their trains. Most important event they're trying to avoid is trains going off tracks. And we've seen that happen in the US, also in my homeland, Serbia. That happened recently, a lot of troubling chemical leaks endangering a lot of people and their health. So Swiss Railways is minimizing that by using the OriginTrail DKG to track pretty much everything in their supply chain. There's a lot of food and beverage traceability applications. I'll show you one on the next slide, which is to me the most interesting because it involves whiskey. And we follow basically the products from grain to glass, and then further tokenizing essentially whiskey and the bottles of whiskey produced by an Irish distillery. And last but not least on this slide, there's applications within the pharmaceutical industry. So again, tracking all kinds of objects such as vaccines, medicines, but also boxes, pallets, so that they actually reach their intended user at the end. In this case, it's also the applications we've done so far are also focused on safety of supply chain. So effectively, the point being that none of the medicine that are supposed to get to a certain patient get diverted somehow along the way. And in this particular implementation, which is a production application, we're tracking medicines and vaccines from the US all the way to India and preventing essentially the event of what they call diversion, which is essentially getting medicines out of the hands of the right people and putting them on the black market. So these are just some of the examples. On the next slide, I'll show just a quick view of these applications. So on the left, you can see this whiskey application, where as a shopper, you can actually scan the whiskey bottle and get all of the information about it from the OriginTrail Decentralized Knowledge Graph, as well as verify the integrity of that information. And on the right side, you see some screenshots from just this application I talked about tracking medicines from US to India, essentially having a map overview of everything that's happening, all of the unusual events. We're basically, with tracking to the DKG, you're able to see all kinds of things, how many items move into one location and how many move out, and if something is a mismatching there. And that goes all the way to the patient, where the doctors actually input and scan the medicines and input them into the DKG, again, in a privacy-preserving manner. As you probably know, the patient data is highly sensitive, and there's a lot of standards covering that. OriginTrail basically supports all of this functionality as it's implemented right now and already in production. So these are just some of the examples that are happening across the globe. There's other applications also being built. They all focus on basically implementing OriginTrail decentralized knowledge graph as the core component. The BUILDCHAIN project we talked about quite a bit. So the idea is to connect the construction ecosystem and share a lot of information in much the same way as I briefly described it through these other previous use cases. So I won't go too deep into it because I don't have an extreme amount of time. I'll just try to cover the details of how it works actually. So how does it work? Let's start with the first question, or the first assertion I'd like to make. And this is actually not my assertion, it's an assertion of one of our advisors, John Keogh, who is a senior supply chain expert. He said trust has two enemies. There's bad character and there's bad data. And when it comes to bad character, that's something we basically cannot eliminate. It's impossible. However, when it comes to bad data, there's a lot of things we can do. We can reduce it quite a bit. And that is one of the core premises that we're applying when we're working and building technology within OriginTrail. Basically tackling the problem of bad data with several different tools. And I'll explain which tools we use. However, the important component here is that without trust, sharing information, sharing data is really not that feasible in a larger scale. And that means sharing, for example, across retailers in the US, like I mentioned, or from the US all the way to India, collecting all of this information, or within Europe, for example, within railway supply chains. So it involves a lot of trust, and therefore tackling trust issues means jumping on the problem of bad data. So what's great for trust? Blockchains are great for trust. They're actually trust networks, really. And what you can build on blockchains is a lot of things. You've probably heard about many of these before. They're essentially tamper-proof shared ledgers. You can build all kinds of things, decentralized identity, tokenized assets. There's quite a bit of a boom last couple of years in decentralized finance. And generally, you can create all kinds of generalized, trusted multi-party computation, something that basically multiple parties can use and can verify and trust because of the properties of the blockchain. However, what blockchains are not is they're not really great databases. In some ways, you can observe them as databases, but if you want to do something in 2023, what we consider a database, doing a database query, performing some search functionality, their blockchains are very, very limited. However, they are great as trust networks, and that's how we apply blockchains within the OriginTrail ecosystem and decentralized knowledge graph. On the other hand, knowledge graphs are entity networks. So what they do is connect entities via relationships. And Google actually coined this term, knowledge graph, about 10 years ago. So they use it, Facebook uses it, NASA uses it, Amazon, Netflix, Uber, pretty much take any big IT industry name and you'll find out that they use it under the hood. And the best and easiest way to explain it to a regular human is to say that the knowledge graphs are about things, not strings. So it's not about raw pieces of text, rather actionable, AI-ready, structured data, which actually becomes knowledge. So with such entity networks, we actually get those desirable database properties. We can query things, we can ask which things are connected to each other, what are the properties of a certain thing, and so on, which blockchains don't offer. So basically what OriginTrail does is it synergizes these two. It takes blockchains and knowledge graphs and puts them essentially one on top of the other. So we have this layered architecture on the left, which basically shows a simple 3-layer structure. Layer 1 are blockchains, so there's actually multi-chain layer here with multiple blockchains. OriginTrail decentralized knowledge graph is on layer 2, but works together with these blockchains in synergy, and then knowledge asset applications are built on top. And as I mentioned, these knowledge assets, they're essentially the key primitive of this system. So I'll explain them in more detail, but they're designed to contain knowledge, to basically enable this knowledge sharing, to support various different standards, and to really be AI grade. Important property of such a system is that it's completely permissionless. So we're not building like a permissioned, semi-centralized, decentralized network. No, this is a completely decentralized system. There's no centralized entity governing none of the layers in here. That means anybody can run an OriginTrail node. It's open source. Anybody can contribute to it, and anybody can share information to using knowledge assets through it. So what are these knowledge assets and what are their properties? They're essentially a new resource for the internet. And they have these following properties. They're ownable. So essentially you can own a piece of knowledge, and that is implemented through NFTs. There you see the blockchain part. They're discoverable. You can basically search for them either by their own unique asset locator, or which are basically a new form of URLs, UALs, or you can actually look for them based on some keyword properties that have been found within the actual knowledge assets. All of the data has integrity, so each knowledge asset, basically all of its knowledge state and the issuer as well of this particular knowledge are verifiable on the blockchain. So you can find their essentially the cryptographic proofs for that. So you take a piece of data, you take proofs, you combine them using certain cryptographic tools, which are also open, and you can verify, aha, this is indeed the data that it was originally shared with the network at the beginning. It hasn't been changed or altered, and I know who has issued it. It can also be private and public. Like I said, a lot of the data in the DKG is private already. It's highly structured, so knowledge assets essentially within themselves can be a graph of their own. They're composable, that means you can connect them. And then finally, their AI grade essentially can be utilized by various AI-based algorithms, and in particular, they're interesting for graph machine learning. So it's a bunch of things. I'll try to illustrate it a little bit better. So what does a knowledge asset look like? Kind of like this illustration on the left, this block scheme. So we have knowledge or the data structured in standardized RDF form on top. It's connected to the blockchain elements, which are this ownership record, the NFT, and the proofs that I mentioned, the immutability proofs, through an identifier that I mentioned, the uniform asset locator, which is the glue for all of this. And all of this together basically is a knowledge asset. It's a container for certain knowledge. And on top of this, the knowledge assets can contain keywords, like I said, so you can find something by a keyword, for example, like typing in keywords in Google search. And to create them, if you're a developer, it's actually very easy. There's a client for the OriginTrail decentralized knowledge graph called DKG client, you guessed it. And when you instantiate it, basically, in case, let's say, of JavaScript, you would do it like this. You would just say new DKG, you provide some options to it. I'll show that in a minute. You want to create a knowledge asset, you would just invoke the assets.create functionality. You want to get one by its URL, which you would get in the first operation. You can just get it by like this from the network. You can also update the content of your knowledge asset, and that's interesting. Only you as the owner are able to update the knowledge asset content. So I cannot update the content of other people's knowledge assets, just like you cannot update, I don't know, content of other people's Twitter profiles. You can only do that on your own profile. Same analogy applies. And the interesting concept as well with ownership here is the transfer functionality. So because the NFT is a core component of a knowledge asset, anything that you can do with an NFT, you can do with a knowledge asset. You can basically launch NFT collections using knowledge assets. You can sell knowledge assets on NFT marketplaces. And all of this is based on obviously standardized NFT technology, fundamentally on this transfer functionality. So anything basically that if you might have been using NFTs so far, you can use that with knowledge assets already. Also, the question is, where do these knowledge assets live? Well, basically, you can kind of guess it by the color coding on the left. they live across multiple blockchains, with the knowledge, the purple being within the decentralized knowledge graph, which is really the center, at the center of the system. And blockchains being used for these additional records, and that enables additional neutrality in the system. Essentially, the more blockchains, the more choice offered to the users who want to use the decentralized knowledge graph. And so far, the decentralized knowledge graph has been deployed in various blockchain networks such as Ethereum, Polygon, Gnosis, and even Polkadot today on a dedicated OriginTrail parachain. All right, so moving on, because there's not a ton of time. I also mentioned knowledge assets really compose graphs. That's a really key property. So because we're using these standardized technologies, we're able to map out the real world or digital environments in very unique ways and very composable. So you can, for example, in this case, you can see an example of a knowledge asset graph that's composed of medicines, doctors, patients, specific events and locations within a certain context. So having such a structure evolve over time, composed by actual multiple actors, such as for example, for buildings in BuildChain, we will have multiple actors build the graph together using knowledge assets. We get one shared, trusted, decentralized knowledge graph that we can query and get all kinds of interesting information from. What is also interesting is once you start connecting things, you actually start triggering something called the network effect. And this network effect basically says that when you have a network of things, connected things, the larger this network, the exponentially more value it has. So the actual formula V is proportional to n squared is called the Metcalfe's law, and actually applied to all kinds of networks so far, from the first networks like Ethernet, which was built by Bob Metcalfe, and Internet to social networks, all basically social graphs, all kinds of graphs. And the same principle applies to knowledge assets today. Therefore, the more knowledge assets within a graph, the more people share and connect information together, the more value is shared for everyone. And essentially, connectivity is the key thing. The gentleman on the left is Bob Metcalfe, actually, who's responsible for that principle before, just received the Turing Award for Lifetime Achievement in Computer Science, and also our advisor. And he basically, together with a few other people, such as Tim Berners-Lee, have built the layers of technology, the Ethernet, the World Wide Web. And what they wanted to do is to create an open permissionless base for all humanity to share knowledge. So OriginTrail extends that. We build on top of all of these standards, we provide choice to users, and we essentially don't connect just computers or just pages on the web, we connect knowledge. And with a decentralized knowledge graph, anybody can do that and contribute and basically grow the value of their knowledge using the network effect. So very briefly, in summary, knowledge assets move from URLs to UALs, which are uniform. Asset locators, so you can have your own uniform address. You can do trusted search and querying on trusted data. And then we move to this paradigm of not just read-write, but read-write-own. So essentially, we get new type of URLs, we have discoverability, and we have verifiable knowledge. It's a really growing ecosystem of knowledge assets that we are observing. There's a lot of companies, businesses, research institutions, and various different partners within the OriginTrail ecosystem. You can see some of them on this slide. And essentially, as the network is growing, so is the value within the network, and therefore the number of knowledge assets really is exponentially growing the value of the entire ecosystem. So I'll finish off with one slide and show a quick demo. And this is another guiding principle we go by the late co-founder of Intel, Robert Noyce, who said, knowledge is power, but knowledge shared is power multiplied. So how can you share this knowledge? I'll show a very simple hello world-like code. So all of this talk is not just nice looking slides, but there's actual meat to the bone. Let me just see where my Sublime text is. Okay, there it is. All right, so there's a bunch of code here. I'll just quickly explain it. Like basically at the beginning, like I said, we instantiate the DKG client. You basically, in JavaScript, you call require dkg.js. If in other languages, Python, you would take the Python client and so on. And in this case, let me zoom in a little bit. We basically take in a certain instantiation of a client to connect to the OriginTrail network. And in this case, we're actually connecting to OriginTrail mainnet. There's different networks. There's a testnet for builders to basically test technology on, build staging applications, but then in production, when you want to leverage the security and all of the features that have been built in the accordance with the slides that I mentioned previously on the mainnet blockchains and mainnet OriginTrail, you would use the mainnet network. All right, and I'll quickly just explain the code. So essentially, we would initially connect to the DKG, and then, for example, we can create some very simple demo assets. So this would be, let's say, a content of a very simple invented building in Slovenia, which is called Green Building on BUILDCHAIN Street number 123. This will be the address. You might notice that this has a specific structure already, which conforms to several models. And for example, in this case, we're using the schema.org ontology and specifically the type of place. And if you haven't seen this before, so if this JSON object looks a little weird to you, this is because this is something called JSON LD, which is an extended version of JSON essentially to support something called linked data. Linked data is essentially at the core of knowledge graph technology, enables these connections between entities and in the graph, as I mentioned. So, but in this case, I'm just showing a very simple one, so we can create this demo asset. And in order to create it, we've just called this function. So this is essentially DKG asset create. We provide this demo asset. We add some additional information. I won't go too much into detail now. We can address that later. And essentially, what we're going to do is we're going to be able to get the owner. I can actually query who the owner is because I'm the owner. It will show the public key address of that's mine. I can also get it, like I mentioned. Then I can also get some specific asset with a specific UAL. This is one format that the UALs come in, and they're based on decentralized identifiers. If you ever heard of DIDs, well, basically the UALs are an extension of DIDs, their own form of DIDs. And then there's a bunch of queries, for example, you can do. Since OriginTrail is built on standardized W3C technologies, RDF and Sparkle, you can write Sparkle queries. And in this case, for example, we can get all buildings from France. We can take a specific asset, in this case, which we actually created for France, and we can say, give me all of the information on buildings. It looks a little bit less human readable because it's a database query, but again, it enables all kinds of different querying. Similar things here, you can query by a certain identifier. You can query by country. For example, here we have a query that gets us all municipalities from Slovenia. So we're gonna look for something that has a country of Slovenia and is actually an administrative area, and so on and so forth. So these are just some of the functionalities outside of creating, transferring, getting. You can also query the entire graph. And in order to run this, I can just quickly run. For example, I already ran this before, but I'll run it again. So essentially, this is a simple Node.js application. Like I said, I should zoom in. Right now, we're creating a knowledge asset on the DKG. What's happening under the hood and why it takes a little bit? It's actually because right now there's a transaction going to the blockchain. And while it's being mined, this transaction is actually minting that NFT that I've showed you on the previous slides. It has previously computed proofs are being stored on chain. The proofs are basically the Merkle hashes of this actually small graph. This is because it's linked data, it's actually in graph form under the hood. And while this transaction is being mined, and it takes a little bit, also the information, the actual content of the asset is being pushed to the DKG, to the network. And all of it, basically now everything has happened while I was speaking. So I can just quickly jump to this. So basically the knowledge asset was created. with a certain UAL. It has a certain assertion ID, and there's certain other details that you can use. Based on this UAL, we have actually now taken who is the owner of this asset, and you can see this is wallet 0x425, etc. So if that changes, if I now transfer this asset to somebody else, this will change as well. Loading the content of the asset is also obviously possible. So basically what we're seeing here is the graph-shaped assertion, or really the same content as you see: green building, blockchain street, BUILDCHAIN street, what we already created, together with the proof. The assertion ID is the proof. So if you were to compute a hash of this, you would essentially get this, and you can verify that on your own machine. You don't have to trust anybody else. Once you have the data and once you have the proof from the blockchain, comparing those is basically a piece of cake, and it's done on in your own environment, so you don't need to trust anybody else. We can also get additional assets. For example, this is the asset with this URL. We see its content. This is actually a representation of country France, an example one, of course. And for example, we have queried here all buildings from France using this URL. So we get a bunch of data. Obviously, this is not something you would use like this. You would use some sort of application to make this more humanized. But since OriginTrail Decentralized Knowledge Graph is infrastructure technology, it basically provides these features under the hood for builders to build knowledge asset applications on top. And like we're building in BUILDCHAIN, we're basically going to be using these features under the hood. And these are just the results of the other. For example, all of the municipalities in Slovenia, we can see the IDs of all of them, like Brje or Banovci and so on. So there's a bunch of them. This is a very simple demo. Obviously, there's much more to go into and learn. I encourage everybody who's interested to jump into the official OriginTrail documentation, which you can find at docs.origintrail.io. So I'll just open that quickly, docs.origintrail.io. And if you go there, there's a lot more on all of the stuff I just talked about on the left. So you can basically find more information about basic concepts, how to use the SDK, how to set up your development environment if you're looking for that, and how to run an OriginTrail node. So this would be a very brief introduction. Obviously, there was a lot of ground to cover. So I'm going to stop here. And I think I went somewhat over time. So I'll let anybody ask any questions they might have and stop sharing.
That was great. Thank you so much. And you actually do have a question. The question was posed by George, participant George, and he's asking on what level trusted search involve blockchain.
Awesome, very good question. So in terms of searching, like I said, knowledge assets contain both of those parts. There's a piece of them on the blockchain and a piece of them in the graph. So when you're actually searching, you're querying the DKG. On layer 2, you're finding knowledge assets, and somehow you get a list of these assets, as I've shown, which then, if for verifiability of all of them, you can call functions that are specific to the type of verification you're looking for. For example, you can verify the integrity, as already mentioned, by using hashes. You can verify the source, because for each of the created assets, you know exactly who created them, because they've all been essentially cryptographically signed. And then there's an additional element to trust. So remember, you're not using some sort of centralized system where you're running this query. Essentially, you're running a query on your machine. So you can, for example, install a node, you can ingest the entirety of the DKG or parts of it that you're looking for, and then perform all of those queries locally. So there's no, in a way, you can you avoid the bias problem that algorithms such as search algorithms can create for you. For example, if we take a little bit of a wider look and we don't think of search as just Google search, but for example, your Twitter feed is essentially a search for give me all the tweets of the people I follow, search query, or you can say search query, give me some recommended tweets, but generally we like to see tweets of people that we follow. Twitter is going to give us something back, but we don't know what it does under the hood. And it does something proprietary. It feeds us maybe a certain agenda, maybe some ads. It's a Twitter thing. It depends on every user to decide, like, do you trust Twitter or not, or TikTok or whatever. TikTok is the big thing now, right? They're just showing videos. But long story short, it's kind of a search query under the hood. So imagine running this on your own machine. You're building an application that users can actually interact with without having this bias. And in case of, for example, BuILDCHAIN project, all of the actors that are going to be using the data shared through the DKG are able to take in all of this data, keep them preserved within their own environment, and essentially do privacy-based trusted search or queries essentially on top of them. So that should answer the question.
Thank you very much. That was great. And there are no further questions. So I will invite our last presenter. We will take a look at the example of the decentralized building logbook. And here we will take a look into logbook based on Web3 and blockchain, the protocol for supply chain traceability and data exchange, and also building log addressing the problems such as finding reliable and trustworthy data, obtaining more complete information. So I'm inviting Purja Miri, a young researcher at the faculty University of Ljubljana, Slovenia. Purja is a student in computer science. I also see that Vlado is here. Okay, he's gone now. Anyway, he's a student at the University of Ljubljana. He earned his master's in physics, and the focus of Purja research is on sustainable improvement, which is based on decentralized technologies. You are invited to listen to his speak and also post the questions you might have in the chat box. There you go, the stage is yours.
Thank you, Katja. Hello, everyone. Good afternoon. I want to discuss about challenge of finding reliable and trustworthy data in context of sustainable construction, and how we can use Web3 technologies and blockchain technologies to address these issues. Before starting, I want to show you interface of our application, and then I will start to explain about this and our application and our approach and so on. Okay. Nowadays we have access to vast amounts of data. However, finding the services or products from the offered set can be a real problem. It is also challenging to find reliable and trustworthy data, as information may be incomplete or insufficient. As I can remember, approximately 40% of energy in the EU is used for building. So buildings are a significant factor in preserving the environment and energy efficiency. To tackle this challenge, the goal of our team is the develop of the decentralized application using Web2 technologies and the blockchain. By using blockchain technology, we can encourage transparency and traceability of funds. To realize our goal, we use the OriginTrail ecosystem, a decentralized protocol for supply chain traceability and data exchange. Branimir explained, so I don't explain more. To develop system, decentralized building log addresses the problem mentioned before, such as finding reliable and trustworthy data and obtaining more complete information in the field of sustainable construction. The developed system can serve as a starting point for further research. In this application, we used some technology and tools. Mean stack is the JavaScript framework for development web applications. MongoDB is a database that uses document-oriented data model. Express.js is a web application framework for Node.js that provides features and tools for building web applications for building web applications such as rerouting and middleware. Angular is a client-side JavaScript framework for building dynamic web application. Node.js is a server-side JavaScript runtime that allows developers to build scalable and high-performance web application. MySQL is an open-source database management. GraphDB is a graph database and knowledge discovery tool that can store and manage the semantic data of knowledge graphs. Ganache is a private Ethereum blockchain environment that can use to host contracts, develop apps, and run tests. DKG.js is an open source library for JavaScript programming language. Branimir explained, so I skipped this section. The basic structure of our application is the user. Okay, you can see my pointer. The user requests the data, and this data in different layers go to the databases, and databases return the request to the user and display data on the client. This is the home page of our application. You can see here, and this is the registration page. In the registration page, you can use other registration. For example, you can use the MetaMask to connect your application to your blockchain currencies. In the reviewing page, you can see different requests that sent before, for example, at 12 o'clock or before that, and the other different building components and services that they are requested. In search page, you can search your product. For example, you can search for a window, for a door, for a chair in the hall room, or other things, or with special materials, for example, wooden, metal, and so on. And in this search page, using a SparkQL queries, you can find your, you can send your request and find your structural. For example, for a roof, this application is in Slovenian. For example, for a roof, you can select measures and services. For example, this one is thermal isolation, replacing thermal isolation. You want to replace your thermal isolation, and you can choose another options you want and services you want. And then you will go to the next step. In next step, you can choose the certain type of materials, and you can choose your, for example, lengths and widths of the material you want, and other specific details of your material. And then you can find some manufacturers, companies, and local persons that can provide the components for you, their phone numbers, their email address, their location, and so on. And for providers, we have a dashboard. They can add or remove their services. They can add their contact details, for example, phone number, email address, their site. They can add their services, their products, and anything they want, and they can provide. In conclusion, the use of Web3 technology and blockchain provides a unique opportunity to address the challenge of finding reliable and trustworthy data in the context of sustainable construction. The decentralized building log is the practical example that addresses this challenge, but there are still many areas for improvement. Testing the solution on the offered decentralized network, improving the user interface, adding functionalities such as rating and commenting would further enhance the system. And lastly, the use of artificial intelligence could make the system more user-friendly, enabling users to describe what they want to search for and generate queries accordingly. Thank you for attention. This is my email address if you have more questions, or we can keep in touch together. Thank you.
Thank you very much, Furia. So there were no questions posed during your talk. Maybe we wait a bit if there are any questions live right now.
Okay.
So there seem to be no questions. Maybe I then can post another one and you can answer anyone. So do you know why did the data scientist break up with his girlfriend? Because he discovered she was a non-representative sample and he only works with the trustworthy data, of course. So there are no questions. Therefore, I will thank all of the speakers. You've presented really great what's the core idea of the BUILDCHAIN project. I hope that you have risen some question marks in the heads of the listeners. We look forward to any reply. You can also find us over the emails speakers shared. So with this, I believe I can close today's session. Thank you very much again for taking time, all of you, and be great. Bye-bye.